All right, guys, we're going to look at complex numbers with trig notation. Trig notation of complex numbers. And here we go. First of all, we're going to graph them. When you graph, whoa, I don't know what just happened right there. When you graph complex numbers, instead of an x and a y axis, we have a real axis, which is our old x axis, and an imaginary axis, which is our old y axis. So when we go to 3, 2 to graph 3 plus 2i, I'm going to go 3 on the x axis, up 2 to 3 plus 2i. If I'm going to graph negative 4 minus I, I'm going to go negative 4 on the x-axis, down 5 on the y, and there, find my point. If it's just negative 3i, I'm just going to go nowhere left or right on the real axis, and go down 3 to find that one. And 2 is like normal, going 2 on your x-axis or the real axis and find your 2. That's others are graphing those. Absolute value, remember absolute value is how far a number is from 0. So in this case, it's how far these numbers are from the origin on the complex plane that we just looked at. So 3 plus 4, let me do this real quick. 3 plus 4 would be 1, 2, 3. 1, 2, 3, 4, up 4 to right there. And what would happen is how far is that from 0? Well, it's that far. It's that line right there. Well, what happened is we went right 3, we went up 4 to get there. And if you look at what that made a right triangle. So this formula right here, it should be the square root. Sorry about that. It should be the square root of a squared plus b squared. Make sure you put that square root in there. My goodness. That's Pythagorean theorem. That's all it is. Square root of a squared plus b squared equals c squared or equals c. So that's all I'm going to do here. So for the first one, I'm going to do the square root of, and don't include the I. The a and the b, if you notice, the b is the coefficient on the I. So I'm going to do a squared, which is 9, b squared, which is 16. Add those up, take the square root, 5. That's all you gotta do. Absolute value is positive. On the second one, square the negative 2, that's 4. Square the negative 1, that's positive 1. You get square root of 5, and that's it. That's your absolute value. 4/5 I is really like 0 plus 4/5 I. So you'd have like 0 squared plus 4/5 squared. If you square 4/5, you get 16 25ths. And if you add that, you get 16 25ths. And if you take the square root of 16 is 4, and the square root of 25 is 5. So it's 4/5. That should have made sense to you. 4/5 I is like 4/5 away from the origin right there. So it's 4/5. Trig notation for complex numbers. This is what the main deal today is. You can take a complex number like this one, a plus bi, and you can write it with trig notation by writing r cosine theta plus I sine theta, where r is the absolute value, which we just found. R is the absolute value. And you can find theta by doing this right here. You can do tangent theta is b over a, and that will tell you exactly what your theta is when you start working these out. So let's try a couple here. It says find the trig notation for each of the following numbers. The first one I give you is 1 plus I. So you need two things. You need r and theta. So let's find r first. When I find r is the absolute value. So I'm going to do 1 squared plus 1 squared, which is square root of 2. There's my r. Now to find my theta, I'm going to do tangent theta equals b over a. B is the number in front of your I, which is 1. A is the first number, which is 1. So where's tangent 1? You can punch your calculator if you need to, but this is one you should know. Where's tangent 1? At pi over 4. Sorry about that. I just sneezed. I hope you didn't hear that. I tried to hit the pause button. Okay, theta is pi over 4. So my trig notation would be square root of 2 times cosine pi over 4 plus I sine pi over 4. Now, you're going to be tempted to work that out because you know what sine pi over 4 and cosine pi over 4 is. But if you work that out and distribute the square root of 2 and all that kind of stuff, you're going to get back to where you started. That's the trig form right there. Just leave it alone. Okay, let's try the second one. Let me change colors here. All right, let's get the second one here. First of all, let's find r. R is the square root of the square root of 3 squared, which is 3. Square root of negative 1 squared, which is 1. So that's square root of 4, which is 2. Now we've got to find theta. I'm going to do tangent theta again. Tangent theta is b, which is negative 1 over square root of 3. If you rationalize that, you get this right here. You get negative square root of 3 over 3. Now think about what this is. Square root of 3 minus, that's actually quadrant 4. So that means tangent would be negative pi over 6. So when I write this out, I'm going to say, or actually be 11 pi over 6 in quadrant 4. We don't want to put a negative angle in there. So I'm going to say 2, r is 2 times cosine 11 power 6 plus I sine 11 power 6. And again, if you were to work that out, if you were to multiply all this out right here, you would get right back where we started. So just a different way of writing a complex number, writing it in trig form, trigonometric form with a sine and cosine. All right. Now we're going to go backwards. They're going to say they're giving us the trig form. They want us to go back to regular notation. So what I'm going to do here is work out what I know. Cosine 120, that's really like 2 pi over 3, which would be negative 1/2. Sine 120 would be square root of 3 over 2 with the I. Don't forget the I. Now I'm going to distribute the 2. When I distribute the 2, it cancels with their denominators, so you get negative 1, and you get I on the square root of 3. And that's all you do. The second one, I have a square root of 8 out here. I'm going to leave that alone for a second. Cosine 7, that's supposed to be pi. I don't have a pi button on my iPad. 7 pi over 4 that's quadrant of 4, so that's going to be square root of 2 over 2. And that's going to be negative square root of 2 over 2 for sine, because it's in quadrant 4. Now when you multiply through there, you get this. You get square root of 16 over 2 minus square root of 16 over 2. Now square root of 16 is 4. That's really 4. That's really 4. 4 divided by 2 is 2, so I get 2 minus 2I when I work that one out. Hopefully no big deal there. Pretty good. All right. Here's how you multiply. We're going to do multiplication and division, and we're going to call it a day. Multiplication, if you have two complex numbers that are written in trig form, there's the first, and you have, there's the first one. Good night. There's the first one. There's the second one. If you multiply them, here's what you do. You multiply their r's together, and then when you get your cosine and sines, you add the two thetas. That's all you do. So you multiply your r's, you add your thetas. Multiply your r's, add your thetas. Watch this. Here's one right here. So all I'm going to do on this one is I'm going to multiply my r's. 3 times 4 is 12. I'm going to add my thetas. 40 plus 20 is 60 degrees. 40 plus 20 is 60 degrees. And then you can do this. Cosine 60 is 1/2. Sine 60 is square root of 3 over 2. If you multiply through, the 2's cancel with the 12. 1/2 of 12 is 6. So you get 6 plus 6i on 3. All there is to it. And the last thing is division. Division works exactly the opposite of the way multiplication did. Division, if I have these two complex numbers in trig form, you divide the r's, r1 divided by r2, and then you subtract the theta. So exact opposite of what we did with multiplication. Divide your r's, subtract your theta. Divide your r's, subtract your theta. Let's try one. Here it is. So I have 2 cosine 3 pi over 2 plus I sine 3 pi over 2 divided by 4. So 2 trig forms. I'm going to divide my r's. 2 divided by 4, first of all. 2 divided by 4 is 1/2, so I'm going to leave the half out here. And then I'm going to subtract my thetas. 3 pi over 2 minus 1 pi over 2 would be 2 pi over 2, which is just pi. I sine, same deal, just pi. You just got to do it one time because you're going to get the same answer both times you subtract or both times you add. Now, cosine of pi is -1. Sine of pi is 0. So when I distribute the 1/2, I get -1/2 because 1/2 times -1. 1/2 times 0 is 0, so it's just -1/2 when I divide those things. And that's all there is to it, all you're doing there. Hopefully that was not too hard at all. And that's how we're doing today. Actually, there's a little more to this section. We're going to split it in 2 days. So I'll see you in class tomorrow. We'll work on this stuff. See you then.